Hi, Jai Hind. Today, we have to discuss our next topic of the determinant is invertible and inverse of a matrix. What is invertible and what is inverse of a matrix? Actually, it is a continuation of our last topic, adjoint. First of all, we discuss the definition of invertible and inverse of a matrix. What is invertible and what is inverse of a matrix? Here, first of all, I consider a matrix A square matrix A. There exists another square matrix B such that AB is equal to BA is equal to, we get an identity matrix. A is any square matrix. There exists another square matrix B such that AB equal to BA is equal to I. Then A is called invertible matrix. A is called invertible matrix. Our first matrix is called invertible matrix. And second is called inverse of first. Also, first is called inverse of B. So, I mean second. That is, A is called inverse of B and B is called inverse of A. Inverse but our first matrix is named as invertible matrix. Okay, so if A is any square matrix, there exists another square matrix B such that AB equal to BA is equal to I. Then A is called invertible matrix and B is called inverse of A. Also, A is called inverse of B. Suppose PQ is equal to QP is equal to I. Then P is called invertible matrix. Q is called inverse of P. Also, P is called inverse of Q. Okay. Suppose we are given only one matrix A. A is given. And its inverse is denoted by A inverse. Denoted by the symbol is A inverse. Raised to minus A inverse. Here B corresponds to A inverse. Then A into A inverse is equal to A inverse into A is equal to, we get answer identity matrix. That's a very important result. If A is any square matrix, then A into A inverse is equal to A inverse into A is equal to, answer is I, identity matrix. Okay, our first definition says that if A is any square matrix, there exists another square matrix B, which is possible only for a square matrix. A is any square matrix, there exists another square matrix B such that AB is equal to BA is equal to I. Then A is called invertible matrix and B is called inverse of A. Also, A is called inverse of B. And our second, you write note. If A is any square matrix and its inverse is denoted by A inverse, then A into A inverse equal to A inverse into A is equal to, we get identity matrix. Here B corresponding matrix is A inverse. A into A inverse equal to A inverse into A is equal to, we get an identity matrix I. Okay. Now discuss how to find the inverse of a square matrix. Here directly we use a formula A inverse equal to adj by dt. First of all, we discuss about singular and non-singular matrix. Inverse we discuss singular and non-singular matrix discuss here. Singular and non-singular matrix. What is singular matrix and what is non-singular matrix? It's a very simple portion. A matrix whose determinant value is equal to 0, that is, A is any square matrix, dta equal to 0, then A is called singular matrix. A is called singular matrix. And if dta is not equal to 0, then A is called non-singular matrix. A is called non-singular matrix. A is any square matrix. If dta equal to 0, then A is called singular matrix. And if dta not equal to 0, then A is called non-singular matrix. It's a very important result. This is mainly used for MCQ type question. MCQ matrix unknown value matrix singular what is the value of that unknown type of question discuss here. This point is very important one. Okay, because this point is very important. A matrix A is said to be singular and dta equal to 0 and non-singular dta not equal to 0. Okay. Now discuss what is the formula for finding inverse of a matrix. Actually, here directly we write the formula A inverse equal to adj divided by dta, where dta not equal to 0, that means non-singular. When matrix non-singular ആയാൽ മാത്രമേ നമുക്ക് ഇൻവേഴ്സ് എക്സിസ്റ്റ് ചെയ്യത്തുള്ളൂ, that means ഇൻവേഴ്സ് കണ്ടെത്താൻ പറ്റുള്ളൂ. Here we use the formula A inverse equal to adj divided by determinant A, adj divided by dta, which is the formula for finding inverse of a matrix. Suppose A is any square matrix already given, then how to find the inverse? We use the formula adj divided by dta. It's very important. Result is here condition is dta is not equal to 0, because if dta equal to 0, then inverse does not exist, because 1 by 0 is not defined and inverse does not exist. So first of all, here we want to find inverse of a matrix. First of all, we find dt value, and if dt value is not equal to 0, then we find adjoint, then using formula we get answer. Now explain how to find inverse using how to find inverse of a matrix. I mean how to find the formula use inverse of a matrix. Inverse of a matrix in the formula we can develop it, but this is not an important for our syllabus, but I will explain. It's not an important factor. Actually, you know the result in our last video we discussed the result that a into adj is equal to adj into a is equal to dta into a. Actually, you know that a into adj is equal to adj into a is equal to dta into a I. Okay, then now dividing throughout by dta, and therefore we get a into adj divided by dta equal to adj divided by dta into a equal to dta by dta, answer I. That means here adj by dta bracket correct here. Here a into another matrix, a into b equal to b into a equal to I. Then you know a is called invertible and b is the inverse of a, also a is the inverse of b. That means this matrix is the inverse of this matrix, that is a inverse is equal to adj divided by dta, and we write the condition dta is not equal to 0. If dta equal to 0, it's not possible. Okay, that is the formula for finding inverse of a matrix. Development important alla, and write next note. If a is any square matrix, then inverse of a is a inverse equal to adj by dta, and condition dta not equal to 0. Okay, main points. First is our definition, invertible and inverse of matrix. If A is any square matrix, there exists another square matrix B such that AB is equal to BA is equal to I, then A is called invertible matrix and B is called inverse of A. Okay, then our second note is, if A is any square matrix, then and its inverse is denoted by A raised to minus 1, then A into A inverse equal to A inverse into A is equal to, answer is I, because B corresponds to A inverse. A into A inverse equal to A inverse into A is equal to I. And third note, A square matrix A is to be singular. Our condition is dta equal to 0, and non-singular dta is not equal to 0. That point is important for finding inverse of a matrix. And our last point, fourth point is, fourth note is, if A is any square matrix, then you find the inverse using the formula A inverse equal to adj divided by dta. If A is any square matrix, then A inverse equal to adj by dta, and dta is not equal to 0. Okay, now discuss some problems based on inverse of a matrix. First question, A is equal to 2, 3, 1, 5. Find A inverse. 2, 3, 1, 5. Find A inverse. Here, first of all, write formula A inverse is equal to, formula adj divided by dta. Adj divided by dta. That's equation number 1. Now we find dta. Dta means determinant of 2, 3, 1, 5. That is 10 minus 3, answer is 7. 10 minus 3, answer is 7. Now adjoint, right, first of all we find m11, minor of the first element, that is 5. m12, second minor is 1. Third element minor is 3. And fourth element minor is m22, answer is 2. And their corresponding cofactor a115, a12 is minus 1, a21 minus 3, and a22 answer is 2. And therefore the cofactor is that means cofactors of the given matrix A. Answer is 5 minus 1 minus 3 2. That implies adjoint of the given matrix is transpose, that is 5 minus 3 minus 1 2. That is the adjoint. And we have substituting 1, we get answer A inverse equal to 1 by 7 dt 1 by 7 into 5 minus 3 minus 1 2. That's all. That is the inverse of a 2 by 2 matrix 2 3 1 5. Now discuss one more question. Finding the inverse. Okay. Here we write a 3 by 3 matrix. Okay, 3 by 3. Find the A inverse. Sorry, A is equal to 1 to 1 0 1 1 2 1 3. Find. Our question is A inverse. You already know A inverse called adj by dt. First of all, we find dt. Determinant of A. That is 1 into row and column delete. Balance 1 1 1 3. Alternate sign change here. Then minus 2 into row and column delete 0 1 2 3. And last plus 1 into row and column delete 0 1 2 1 is equal to 3 minus 1 is 2. 0 minus 2 minus into minus plus 4. 0 minus 2. Answer is 4 is not equal to 0. Okay, 3 minus 1 2. 0 minus 2 minus 2 into minus 2 plus 4. 0 minus 2. And therefore answer is plus 4 is not equal to 0. Now we find the adjoint. How to find the adjoint? You already know minor and cofactor. First of all, we find minor and cofactor. Minor M11. M11 means first column delete. Balance and digit value 1 1 1 3 dt is 2. Then M12. M12 means first row second column 0 1 2 3 and digit value is minus 2. M13. First row third column 0 1 2 1 and digit value is minus 2. 0 minus 2. Then M21. Second row first column. Second row first column 2 1 1 3 6 minus 1. Answer is 5. Then M22. Second row second column 1 1 2 3 3 minus 2. Answer is 1. Then M23. Second row third column. Second row third column 1 2 2 1 1 2 2 1 is equal to 1 minus 4. Answer is minus 3. Then third row first column M31. 2 1 1 1 2 minus 1 1. Then third row second column. Then third row second column. What is third row second column? 1 1 0 1. Answer is 1. And third row third column 1 2 0 1. Answer is 1. And therefore the cofactor is A11. Answer is 2. A12. Answer is 2. Sign change. A13. Answer is minus 2. A21 minus 5. A22. Answer is plus 1. A23 plus 3. A31. A31 is 1. A32 minus 1. And A33 is again plus 1. Alternate sign changing. And therefore the cofactors of the given matrix 2 2 minus 2 minus 5 1 3 1 minus 1 1. Okay, A11 A12 is plus 2, A13 is minus 2, A21 is minus 5, A22 plus 1, A23 plus 3, A311, A32 minus 1 and A33 plus 1. And therefore the adjoint, that implies adj of the given matrix transposed. Yeah? That is 2 minus 5 1. Then 2 1 minus 1. Then minus 2 3 1. And therefore A inverse 1 by dt. Dt, what is dt here? 4 into 2 minus 5 1. 2 1 minus 1 minus 2 3 1. That's all. It's a very important result. A inverse very important problem. So we do some more problems based on this topic. That will give a better idea. Okay. Then A inverse formula is adj divided by this dta. Okay, that's all. The next class we will discuss more problem based on inverse. Bye.